Muy buenos días, bienvenidos todos nuevamente a la continuación de estas conferencias y en esta ocasión yo quiero presentarles a una gran personalidad, nuestro conferencista especial de este día, George Gorospe, ingeniero de investigación en el Centro de Investigación AMES de la NASA, trabaja para traer inteligencia para sistemas de ingeniería en aviación y vuelos espaciales, como gerente del Laboratorio de Análisis de Salud de Sistemas, Resiliencia y Modelado de la Física. George lidera el desarrollo de sistemas de prototipos y de nuevos bancos de pruebas para la investigación de modos de falla, de componentes y de sistemas. Actualmente él lleva un proyecto con estudiantes de todo el mundo que se llama START. Bienvenido a nuestro ponente, George Gorospe. Welcome, my friend, and go ahead. You are with the students.
Yeah, great. Thank you so much, Francisco. Thank you to all the students who are tuning in today. I'm so excited to talk to you about artificial intelligence and the work that I do at Ames, but also the work that I do with students as a part of my project called STAR, where we help to teach students how to work with artificial intelligence, how to write their own artificial intelligence, and how to use it to solve problems around their part of the world. This is introduction to the types of things that I do and why artificial intelligence is important. So what I've decided to call this is the human connection to artificial intelligence. This is actually very important that we consider the human connection to artificial intelligence, not just what artificial intelligence can do, but what it can do for us and how important. About me, I'm from Albuquerque, New Mexico, and now I'm a research engineer in the Diagnostics and Prognostics Research Group in the Intelligent Systems Division at NASA. But I always remember that I started in New Mexico. I went to the University of New Mexico, where I studied mechanical engineering and robotics, and eventually I worked hard and I found myself at NASA, where I now lead a research laboratory. And you can see my laboratory there and many of the students that come to visit me to learn about the types of work that I do there. So as we start to talk about the human connection to artificial intelligence, I'm going to give you a gentle introduction to AI, and then I want to think about problem solving with AI. There are many big problems in the world today, and some of those problems can be solved with AI. It's even better when we have the opportunity to solve problems. And we use student programs for AI to teach students how to use AI. And finally, we'll explore a little bit our own connection to AI. You see, the world of artificial intelligence is actually very broad. There are many parts to it, from machine learning, natural language processing, speech, robotics, and vision. And each of those have their own portions, from machine vision and image recognition to speech to text and text to speech. This is how some of our digital assistants can speak to us in a more natural tone. Deep learning and predictive analytics, these are really, really important parts about the future of artificial intelligence. And there's so much to explore, but first we have to do some important work. We have to clear up misconceptions about artificial intelligence. You see that we have things like artificial intelligence, machine learning, and autonomous systems. Well, a portion of that is driven by Hollywood and entertainment and science fiction, which gives you some beliefs about what artificial intelligence is and what machine learning is. But those aren't always true. There's not a direct, hard connection. There are lines in between this because it isn't direct. It is ideas, concepts about the future of artificial intelligence that hasn't happened yet. But if we can change this and move it to this, hard connections between artificial intelligence, machine learning, autonomous systems, and problem solving. You can use artificial intelligence for problem solving. You can use artificial intelligence for empowerment, to increase the quality of life, for opportunity. You can start companies with artificial intelligence, with machine learning, with our autonomous systems. You can learn more and do more and fix things around you. There's more opportunities to use these to make the world a better place. So these are the hard connections, things that are a direct correlation. And when we start to think about AI, we have to ask ourselves a fundamental question of AI. If I had an AI right with me right now, and if you had an AI with you right now, what do you want to teach your AI? Remember that it's the humans that teach the AI. And so we have to ask ourselves, what do we want to teach our AI? Keep thinking about that. Think about what it is that you care about. Think about what it is that you want to fix. Those are the kind of things you want to teach the AI. So I understand that AI can feel complex from the very beginning. There's lots of parts to it, and you think that perhaps only the smartest people in the world get to work on AI. And I think that's not true. I think that there's room for many different types of people to work on artificial intelligence. So I'm going to give you a gentle introduction to AI. And it starts in the 1950s with Alan Turing and his early thoughts on AI. You see, Alan Turing was a highly influential English mathematician and computer scientist. He came up with concepts like the algorithm, computation, and the Turing machine, which at the time could and still is considered a general computer. Here, general is really important, especially when we consider that many engineered systems of the day and the following decade even were highly specific, and many times only performing a certain numeric calculations. What's important here about Alan's thoughts on artificial intelligence is that he considered how to imitate the adult human mind. And this is really important. There are three parts to it, he said. Well, if we think about imitating the adult human mind, we have to start with the initial state of the mind. That's right, like a baby's mind at birth. That mind is like a sponge and can suck up information. Well, that's what Alan thought. And he said, we start with that infant's mind and subject it to education, and then even to other things which gain experience, not necessarily education, but the experience about what is the world around you? How does the world around you work? These are the early thoughts about artificial intelligence, and it had a lot to do with how you learn and how you copy the mind. So there's a real killer question that arises from this. How can we imitate the human mind with math? This is a big question. Later on, as we got further more and better understood our own mind, we came up with some answers. And one of the answers is biomimicry, a way to model the structure of the brain. Biomimicry is a practice that learns from and mimics strategies found in nature to solve human design challenges and find hope along the way. Hope that we can learn from who we are and use our natural abilities to solve other bigger problems. So what does this look like? How do we imitate the human mind? Well, an initial model is called the neural network. The neural network focuses on different components of things like an image and separates it into smaller pieces. And those smaller pieces are passed through other layers, identifying different features in the image. So in this image, we have a cat and a dog. And we might say, how can we identify different cats from different dogs? Well, we see Each has two eyes, each has two ears, each has a mouth and a nose. But what is it that really differentiates these things? We have stacks of images that are fed through this neural network-based classifier. And eventually, the classifier is able to realize what differentiates a cat from a dog by looking at small areas of each of these images and saying, what is important about this image that makes it a dog? And what is important about this image that makes it a cat? What we see here is actually an algorithm. And the values in this algorithm, there's so many of them. Sometimes there can be billions of values in this algorithm. So many that a programmer could never program that. Instead, we rely on artificial intelligence to program that algorithm for us. And then we can finally have something that does exactly this. But let's dive in a little bit deeper and look at an example. This is a real example. This is something that actually works. Example number 1, a handwriting interpretation artificial intelligence. You remember when I asked you, what do you want to teach your AI? Well, this is my answer. I want to teach an AI how to read my handwriting. Well, if you look at my handwriting, you might say, good luck. My handwriting can be somewhat messy. This is perhaps typical of an engineer. The letters are not so great and not so consistent, but the numbers are very consistent. If you look at the twos, all the twos are fairly consistent within this sample of my handwriting. But if you look at the E and the C as in aerospace, the E and the C look very, very similar. Is it possible that we can train an artificial intelligence to know the difference between those two things? The X's look similar. Well, let's look at the way that this is done. To start, we're going to need lots of data. This is data. This is my handwriting, examples of my handwriting. But we need more than just data. We need data plus labels. Here is a label. This is the form. This is what it means. This is the form. This is what it means. Labels are equivalent to meaning. If you saw writing in a different language, you wouldn't know the meaning of it. We need to add labels to the information so that we can get meaning from it. But this is only 5 pieces of data. We need lots of data. Fortunately, we have a data set example. The US National Institute of Standards and Technology produced a hand-printed forms and characters data set. This data set has 800,000 characters, like this, isolated and hand verified, collected from 3,600 different people. And that's available here. So what can we do with all that data? You got it. We can train our machine learning model to identify letters and forms. We take all of these and we use those to feed into our algorithm, our neural network. And then our neural network can identify what we've written. Let's look at a real example of this. So here we have a demo of a trained neural network. And we can just draw a letter, our number. So this is what I've drawn. This is what the AI sees. Let's refresh this real quick. Okay. And this is what the AI thinks it is. The AI thinks that this drawing, this interpretation of the drawing, is actually a 2. But let's try a 3. The AI thinks this is a 3. Now let's look at a 4. A 4 can be really interesting. So between the two different AIs here, one of them thinks it's a 9 and the other one thinks it's a 4. right? The difference between a 9 and a 4 is very small. Let's try a 9 now, right? In this case, neither one thought it was a 9. And let's try a different form for a 4. In this case, both machine learning models thought it was a 4. This one is very convinced that is a 4. If we draw a 1, it thinks it's a 1, and it thinks it's 2. What if we add the base to the 1? How does that change? This one became even more convinced that it's a 1, and this one didn't change. This is a real life example of how an artificial intelligence can do something that is very specific. In this case, figure out what I'm drawing, the meaning behind what I'm drawing. And yeah, it's not always perfect. And this is very representative of artificial intelligence in general, that it doesn't always work perfectly, but still sometimes it works to do the things we want it to do. Going back to the presentation, the next thing we say is, okay, well, we have an example. We've shown us, George, how to use artificial intelligence to how to train it. But if we've got it, what do we want to do with it? Fundamentally, we should think of artificial intelligence as a way to solve problems. I'm an engineer at NASA, and I've got to tell you about engineers at NASA. We love to solve problems. We love to solve the most difficult problems. We love to think about what is it going to take to put the first woman and the next man on the surface of the moon. And when you're solving problems, especially with AI, we use this type of workflow. At the very top, we collect data, and then we label that data, just like the data that we had earlier with the numbers. We label it, and we use that labeled data to train artificial intelligence. Once we have artificial intelligence trained, we can define the logic that comes from the artificial intelligence. We deploy and test the AI, and we see how it does. And we can see if does it work as well as we want it to, or was there a problem like what we just saw? It doesn't always work. Well, if it doesn't work the way we want to, we go back to collecting data and labeling the data and try again. So it's very cyclical. There's always more to do. And it's important, in practice, AI can be used to solve very specific problems. A big part of setting up and using AI is setting up the problem so that the AI does exactly what we want. So what we have in this picture here are two things. We have a road and a tunnel for a train. Now, trucks and trains do very similar things. They both carry cargo. But we couldn't put a train on the road, and we couldn't put a truck on the railroad, right? We have to set each of them up with their specific, the setup for each of them is very, very important. The setup for the truck, it needs a good road. And the setup for the train, it needs a good railway. And AI is just like that. We have to set up the problem so it does exactly what we want. In some cases, the AI can be trained and optimized for an action that produces the highest reward or the lowest penalty. But the problem is that AI has a very limited concept of consequences. If it does the wrong thing, well, then it gets less reward. But if you and I do the wrong thing on the highway, maybe we get a speeding ticket, right? Or maybe we crash our car. And that's a very important consequence for us. But the AI doesn't always understand that consequence. It often thinks of reward and penalty. This is a result of limited contextual knowledge or information. It doesn't understand the context of where it's operating. And this is a big problem in artificial intelligence. This is actually a very key problem. So as an engineer at NASA, as somebody who loves to solve problems, I started a project to solve just this problem. And this is really important, especially for the students that are listening today. because this is the project to solve that problem. It's called Students and Teachers Assisting Real Research. The STAR project, specifically STAR Project 2020. And here we see two of the robots involved in the STAR project. The key question of the STAR project is, can we integrate high school and community college students within cutting edge research? The type of research that graduate students work on, the type of research that engineers at NASA work on. Can we give that research to high school students, and can they be successful? Well, the answer is yes. The students, nearly 60 students that myself and Russ Fisher-Ives of RoboRave have contacted and worked with as a part of the STAR project. Those students from high schools in the United States, in New Mexico, in New York State, in Japan, in Colombia, in Poland, and even more places soon. Those students are building their own robots. Those students are learning and programming artificial intelligence on their robots. Those students are solving real problems with artificial intelligence. These are students that maybe didn't have a lot of programming experience even a few months ago, who are now programming artificial intelligence. And that is the exciting part about STAR, is that you don't have to have a PhD in computer science to solve problems with AI. Problems exist all over the world. All you need to do is have a little bit of experience and do something like what we're doing with STAR. And when we start to talk about artificial intelligence and context, what students are learning in STAR is about the next generation of artificial intelligence. You see that there's actually generations to it. The first generation used rules and logic and said things like, if this happens, then that should happen next. If the light is green, then I go. If it gets too hot, turn down the thermostat. The second generation learned from examples. If I turn the heater too high, then the house gets too hot. If I drive too fast, then it's harder to control. These kind of AIs learn from doing, and that learning helps to teach the AI what to do next. But there's a next generation, and this is what the students are working on. This next generation of AI has an awareness and an understanding of its contextual information. So what we want our students' AI to say something like, I know where I am, so I should do this. I know what that thing in front of me is, so I should do this or that. Now, this is really interesting, and let's look at a few examples of that. In the first image, we see somebody reaching for a book and somebody studying behind on a desk. We want our robot to say, I know where I am. I am in a library, so I should look for books. Or maybe I should put books back on the shelf. Or maybe because it's a library, it's very quiet, I should operate in quiet mode. This is information that the robot gets from its surroundings and uses to change its behavior. All because the artificial intelligence knows where it's at. Let's look at the second image. We see nurses, doctors, patients, rolling beds. We want the robot to say, I know where I am. I'm in a hospital. So I should be very careful around patients. I should help move items like medicine to patients, or I should take information from patients and deliver it to doctors. These are actions. These are ways that we can integrate a robot in a hospital. But if we're going to put a robot in a hospital, the robot needs to understand that it is in a hospital. That's a very, very important part of this. And now if we move on to the third one, well, we see a beautiful green field, a farmer and his tractor. And we say, okay, how can we integrate a robot in here? We want the robot to say, I know where I am. I see the plants. I see the sky. I see the tractor. I should help look for bugs on the plants. I should help deliver fertilizer to the plants that need fertilizer. I should look at what plants are healthy and are not healthy because I know I am on a farm. We want to tell the AI how to behave or what to do when we are in real complex environments. So how does this all start? This starts by sending the AI to high school. Yeah, we're going to send the artificial intelligence to high school. We want our high school students in the STAR project to teach AI about what happens at high school. Yeah, so when we see a hallway full of students and a hallway with no students, the AI should operate differently in the same environment, right? When there are many students, the AI and the robot need to be very careful not to get stepped on. But when there's nobody in the hallway, the AI can use the center of the hallway. When the AI is in the library, it should operate quietly. And when the AI is in the cafeteria, there's an entirely different set of behavior, right? And what we're depending on is the students. We want the students to teach the AI. We want the students to show the AI their school and tell it what to do there. And it's as simple as this. This is the cafeteria. The walls are white, the chairs are blue, and there are wood stripes on the ground. You should be in the middle between the tables and you should enter and exit through these doors. Now that's very simple, right? This is actually how we want to teach the AI about our school. And we leave it up to the students to do that. And the students actually do that through photographs. They take photographs with their robot. The robot can be controlled and moved around the cafeteria and shown what's there. But now during COVID, the students are not at school so much. They're often at home. So we ask the students, what kind of objects do you find in your home and what role could a robot play in your home? So all of our students have taken their robots home. And they said to the robot, this is my bedroom. The bed is here, the desk is here, and there's carpet on the ground. You could say things like, move the dirty clothes to the closet and the video game controllers to the TV. These are things that we can teach an AI how to do. Because unlike a vacuum cleaning robot there, our artificial intelligence robots, they know what dirty clothes are. And they know what video game controllers are. When we equip the robots with advanced intelligence, they can do advanced operations for us. Even something that is super valuable, like monitoring the doors of the house. We show the robot the front door and the back door of the house, then we can tell the robot, please monitor the doors while I am at school. These are very general problems, but these are also ways where we can approach all of those problems using artificial intelligence. And the really exciting thing about it is that it's high school students who are doing this with us. So the last thing I want to talk about is actually a connection to AI. We've looked at a couple different ways that AI can be trained and used. But the first thing we need to look at, we don't want to focus right away on artificial intelligence. It's often better to focus on the problems that we see in our world. When we look around and we see things like not enough food and people starving, we might say, how could we use artificial intelligence to increase food production so that there's more food for everybody to enjoy? when we say our streets are dirty or there's trash in the park, could we teach an artificial intelligence and a robot to clean up in the park for us so that we can have cleaner parks? These are our problems. So when we identify problems in the world, I want you to look around and think about, what do you want to change and what do you want to fix? And once you get that, we can create data or utilize the data that exists to gain new knowledge. We say, oh, okay, there are many farms around us, but some of the food is wasted. And I found data that shows that the food is wasted. Or maybe the energy company in our country says we're using too much energy, and different parts of the day there's too much energy. Can we use artificial intelligence to help tell people during this part of the day, turn off the lights or try to use less energy because it's affecting our environment and causing global warming? These are problems that we can solve with data. And even though sometimes solutions exist for problems, they're not always the best. New solutions to old problems may yield additional insight. They can be better, especially when we use new solutions like artificial intelligence. Old problems that were solved in the past, well, let's apply artificial intelligence to them anyway and see what more performance, what benefit we can get. And finally, this is actually a very, very important part. New technology leads to new ethical implications. There are problems associated with artificial intelligence. People worry about artificial intelligence taking jobs. People worry about artificial intelligence doing various things. It isn't until we know and understand it. We don't have to have a deep understanding. We just have to have an opinion about it so that we can understand the ethical implications and also inform others. A big part of that is clearing up misconceptions. You know, when we think about all of these, it's easy to think about science fiction and the way we might see our future to exist. And you know, we're not the first ones to have to think about that. Over 100 years ago, there was a brand new technology. It was called the automobile. And this new technology was at the time very strange, especially because people regularly used horses and horse and carriage systems to get around. And finally, this technology that doesn't have a horse, this technology that makes loud noises and doesn't always work. What could this technology do for us, they thought? Is this technology ever going to be widespread, or are we always going to be using the horse? Some people didn't like the car and resisted implementing and using and adopting the car. But if we think about the way that technology has shaped our world is highly dependent on automobiles. And we see it when we look at the infrastructure around us and how there are many, many things that we've built simply in support of that technology. So from 100 years ago, when people didn't really accept or had some skepticism about whether or not this new technology was going to be important for the future, to today, when that technology is a very big and very fundamental part of our daily lives, and how it has formed many parts of the way we live and work and get around. AI can be just like that, but we have to accept it too. We have to understand the ethical implications of it, and we have to look for ways that we can use it to solve the problems that are important to us. So I've given a lot, there's a lot there to think about. And this is just a gentle introduction to artificial intelligence. But the important things to think about are how artificial intelligence can be used to solve the problems that we see. I live here in Silicon Valley in California, where people are working every day with artificial intelligence to solve the types of problems they're thinking about. Maybe those problems are self-driving cars or flying taxis or banking systems. But those aren't the only problems in the world. They're probably problems where you are right now. We need people to solve those problems, and artificial intelligence can be part of that process. What I really want you to understand is that artificial intelligence is something you can employ and something you can learn and actually use. The things that we're doing in the STAR program have shown me that students, even in high school, can learn and use artificial intelligence. And so that means college students can use it as well. I'd love to hear some of your questions. I want you to understand that you can too use artificial intelligence. And I want you to think about, as you're walking around, the types of problems you want to solve. Again, big thank you for your patience, and thank you, Francisco, for giving me the opportunity to talk to all the students here. It's really my pleasure.
Thank you very much, George. For us, I think that it's a very nice conference for me, especially, and I think that all the students can be something with artificial intelligence. Muchas gracias, jóvenes. Podrán preguntarle a George por correo. Yo le podré hacer llegar sus preguntas y recuerden cuidarse, pues usar el hashtag CapitalRobotia 2020, seguir la agenda. Ya están las conferencias que pasaron, pueden verlas ahí, pueden suscribirse a nuestro canal de YouTube, que es Mejora Channel, y bueno, pues recuerden que la actitud que pongan, pues van a lograrlo. Y lo que nos decía aquí ahorita George es que la inteligencia artificial se está aplicando día a día, donde él vive, allá en el Silicon Valley. Entonces, pero no nomás allá, se utiliza, ¿cómo la pueden utilizar ustedes estudiantes? Entonces, este es el reto a lo que George nos invita, y que pues próximamente a lo mejor dentro de nuestra plataforma podamos tener un curso de inteligencia artificial. Pues George, te agradezco. Thank you very much for your participation, and I don't know, but thank you. It's a very nice conference. If you want to say something or finish your presentation, or because for me, totally
good
for this presentation, my friend.
Well, Fernando, thank you, Francisco, for the opportunity to talk with the students. I want to give all the students a hope that you can use this technology. You can learn it. It's not too complex. And furthermore, you can use it to change the world around you. I think that's the most important part of this.
I think so, too. Thank you very much, George. Gracias a George. Gracias a todos. Nos estamos viendo. Que tengan una linda tarde. Bye, bye, George. Thank you. Y seguimos.
Enjoy the rest of the conference.
Yeah, thank you very much, George. Have a nice day. See you.